Have you ever really stopped to think about what happens to all that salt we dump on our roads every single winter? I mean, it has to go somewhere, right? Well, today, we're going to pull back the curtain on a hidden and frankly kind of scary consequence of keeping our streets ice-free.
And that right there, that's the unsettling idea at the heart of this whole thing. It suggests that a slow, silent change is happening right under our feet in a place we've always just assumed was totally pristine and protected.
Okay, so let's just get right into it. This is the big question, isn't it? On one side, we have this tool we absolutely rely on for winter safety. But on the other, what if it's causing permanent damage to one of our most precious resources?
To really get what's going on, we first have to bust a myth that a lot of us believe. This idea that our groundwater is somehow invincible, totally shielded from whatever we do up here on the surface.
You know, for the longest time, we've had this picture in our heads: rain falls, snow melts, and by the time it trickles all the way down through the earth, it's been perfectly filtered, pure and clean. But, well, our modern cities are throwing a major wrench in that system. So how do we know this? Well, scientists who were monitoring these ancient natural springs started picking up on a chemical signal that just didn't belong. It was a discovery that pretty much shattered that whole myth of protected water.
And this is where it gets wild. Look at this comparison. Geologically, you'd expect to see a pretty steady mix of minerals from the rock, stuff like calcium. But what they were actually finding was this crazy chemical roller coaster, with these massive spikes of chloride, the key ingredient in road salt, showing up right after winter.
And this chart just lays it all out there. We're not talking about a small increase. The chloride levels after winter are just skyrocketing compared to what's naturally supposed to be there. This isn't some subtle hint, it's a blaring chemical alarm bell.
So this is the big mystery for researchers, right? If the ground is supposed to be this amazing natural filter, how in the world is so much salt making it hundreds of feet down into these deep, old aquifers? Well, the answer is kind of written into the blueprints of our cities.
All right, let's play detective. We're going to trace the journey of a single grain of road salt, following its path from a slick highway all the way down into the deep earth.
It all starts out simple enough, right? The salt dissolves in the melting snow. But here's the twist. Instead of slowly seeping through the soil, this super salty water finds an express lane. Think storm drains, utility tunnels, all these urban shortcuts that let the contaminated water completely bypass nature's filtration system and shoot straight down to the groundwater.
And here's the kicker. This doesn't happen overnight. Once that salty water hits the aquifer, it moves incredibly slow. This idea of residence time is absolutely crucial because it means there's a huge delay between the cause and the effect we can see.
This timeline really puts it into perspective. The crazy high chloride levels we're measuring in a spring today, that might not be from last winter's salt. It could be from salt that was put on the roads back when the internet was still a novelty. We are literally seeing a chemical echo of decisions made decades ago. And that delay? Well, that leads us to the most serious part of this whole problem. This isn't just pollution that's going to wash away next season. We're talking about a fundamental and maybe even permanent change to the chemistry of the water itself.
So here's how it happens. As that salty water seeps through the ground, the sodium in the salt basically plays a game of chemical musical chairs. It kicks the natural minerals like calcium right off the rock and soil particles and takes their place. The water itself is literally being re-engineered at a molecular level.
And the fallout from this is very real. I mean, sure, the water tastes different, but way more important, it becomes more corrosive. It literally starts eating away at city pipes and infrastructure, which you can imagine creates a huge economic headache. So this isn't just an environmental problem, it's a massive engineering and financial one too.
And this is the invisible legacy they talk about. See, chloride is super stable. It doesn't just break down or go away. It has been building up in our aquifers for decades, creating this huge underground reservoir of salt that's going to keep slowly leaching out for generations, even if we stopped using road salt tomorrow.
And we can't forget about the biology. Down in the dark, there are entire hidden ecosystems full of tiny organisms that have adapted over millennia to live in pure, stable water. For them, this sudden rise in salinity is a catastrophe. It's completely disrupting their world.
Okay, so that all sounds pretty bleak, I know, but it's not hopeless. Now that we know what's happening, people are actually starting to figure out what to do about it, how to try and reverse this salty tide.
And the good news is there are some pretty smart solutions. Things like using brine instead of dry salt, which is way more efficient. Or building more green infrastructure. Rain gardens and special pavements that let water filter naturally. It's all about being smarter, working with nature, and finding that tricky balance between keeping people safe in the winter and keeping our water healthy for the long run.
And that really brings us right back to where we started. That ancient spring, it's still there. It's still flowing, just like it has for centuries. But the story that its water is telling, well, that has completely changed.
That water isn't just a pure reflection of the rocks and soil anymore. Now, it's a hybrid. It's part geology, sure, but it's also part human history. It literally carries a permanent chemical signature of our cities, our roads, and our need to get to work on a snowy day.
So, yeah, the debate isn't really if this is happening anymore. The science is pretty clear. The real question is for us. Now that we know our actions have this deep, lasting impact on the hidden world beneath our feet, what are we going to choose to do about it?